Better, better, better. Oh, it's Friday. Thank goodness. Alright, let me get this thing straightened out and then we can get cranking. Hold on. I think that goes lower, lower, lower. Upper, upper, upper. Okay, perfect. Okay, so for today we're going to, this is the tutorial on problem set number 9, oscillations and some other stuff. The one thing I'll say is on the 1 o'clock lecture, we did, in the last 20 minutes, we did problem 9. So rather than reinvent the wheel, just look at the lecture from today's 1 o'clock lecture and you can see how we did this. So it is, it's kind of a hybrid problem. It uses buoyancy and torque. So it's a little bit different. And what, in terms of the grand scheme of how I see the class going, the first 2 tests were just getting information out there and seeing if you can do basic stuff. Now that we're in test 3 material and next semester, we can start changing things up a bit. I can start taking different fields of physics and putting them together. For those of you who are taking the MCAT, my hybrid problems, you can think of them as passage problems. They take a whole jumble of stuff, mix it together, and expect you to understand what's going on. So where do we start? Now, I do not have my calculator, so I'm going to let you guys, I'll get it to the point where all you have to do is plug and chug, and then I'll move on to the next one. So which one are we going to go with? Or do we just sit here and nap? I vote for nap. What do you want to talk? 1? How creative. Never saw that coming. All right. Now, number 1 is a spring pendulum, because I'm asking for spring constant. And the period for a spring is 2 pi, m over k, I think? Yes. M over k. Because the bigger the mass, the bigger the period, the stronger the spring, the shorter the period. I give you the mass, and I give you frequency. By giving you frequency, then you just write this down. So if I give you frequency, just use that instead. What is the spring constant? Then you just solve for k. F squared, 1 over 4 pi squared, k over m. So it is 4 pi squared m, F squared is equal to k. If you doubled the mass, how would the period change? So T prime is 2 pi m prime over k, where m prime is 2m. Substitute. Pull that square root of 2 out. So it's the square root of 2 times 2 pi m over k. And that's t prime. And so t is square root of 2 times your old period. So by doubling the mass, you increase the period by square root of 2. Or a factor of square root of 2. If you double the gravity, how would the period change? Wouldn't change at all. because it's not gravity dependent. There is no G in the period equation. So we get that. I'm gonna nap.
What is that on the last
You mean this?
Yes.
This over here. That says that the new period is the square root of 2 times the old period.
Oh,
So if the old period was 2 seconds, you would multiply it by square root of 2, and that would be the new period, if you doubled the mass. Number 2. Physical pendulum, and really it should be simple pendulum, period of 4 seconds. So with a simple pendulum, it's 2 pi L over G. T is 4. If its mass is 5 kilograms, what is the length of the pendulum? You don't really need to know the mass because it only depended upon gravity. And when in doubt, if I don't tell you, you're on Earth. So in this case, some people said, well, what if I'm on the moon? Well, I didn't say you're on the moon. I just said, we've been dealing with physics problems for the last 3 months where everything is on Earth. I'm not going to change it unless I tell you. So this becomes T squared, 4 pi squared, L over G. So G, T squared over 4 pi squared is L. So we got the length of the pendulum. If you doubled the mass, how would the period change? It wouldn't change at all because mass is not a quantity that the period depends on. It depends on for a spring, but this is a simple pendulum. If you doubled gravity, you would do the same thing that you did before. T prime is 2 pi L over G prime. G prime is 2G. So this means its T prime is 2 pi L over 2G. 1 over square root of 2. 2 pi square root of L over G. So this is T prime is equal to 1 over the square root of 2 times your old period. So if you doubled gravity, the period would decrease by a factor of 1 over square root of 2. Okay. To number 3. A 1 meter long guitar string weighs 12 grams. M is 12 times 10 to the negative 3 kilograms. L is 1 meter. Its fundamental frequency is 300 hertz. So F1 is equal to 300. That 1 designates its in value. Find the tension. So frequency is N over 2L square root tension over lambda. Lambda is mass over length. So this becomes F equals N over 2L T big L over M for that. Square both sides. One of the L's cancels. Solve for t. And you got it. After this tension is doubled, what are the first three overtones? So for the first three overtones, you're dealing with N being 2, 3, and 4. For the first three overtones for a string, that represents N's of 2, 3, and 4. The tension is doubled. So frequency is N over 2L square root of 2T over lambda. So what you're going to do is you're going to plug in a T of twice that of the answer from part A. So take this value, plug it in there, multiply it by 2, and actually, yeah. Oh, move it up. So T is 2 times whatever A is, which is that tension. Plug it in there. Lambda is still the same, M over big L. And then the big thing is, plug in 2, get a frequency. Plug in 3, get a frequency. Plug in 4, get a frequency. It's repetitive. You plug in, you take that T that you get from part 1, you double it, so now you got T prime, and that T prime goes in there.
What is A?
A is, well, I really should, A is the T from part A. So it's right that.
What is N in part A? How do you write it?
Oh, fundamental frequency. What's the N for the fundamental frequency? 1. So the N for this part is 1. Okay. So that's it with number 3. Number 4. Simple pendulum 1.4 meters long has a 100 gram mass at the end. That's irrelevant. In Lewis Hall, what is the period of the pendulum? So for number 4, that period is 2 pi square root L over G. In this case, G is 10. You then take the pendulum to the moon and measure the period again. What is the new period? So T prime is equal to 2 pi square root of L over G prime, where G prime is 10 divided by 6. Done. So 4 is that fast. We got it? Number 5. Spring constant, 200 newtons per meter, is in a spring pendulum. 100 gram mass at the end. What is the period in Lewis Hall? So 5t equals 2 pi m over k. M is 0.1, k is 200. Now you got the period. You take this pendulum to the moon and measure its period again. What is the Newton period? It's the same answer, yes. You don't even have to do any math. You say, it's not gravity dependent, so the period doesn't change. Therefore, the period is put in whatever you got for the first one. Very good. Number 6. Well, first off, what am I doing with a silver spring? That sounds awesome. 3 kilograms mass on a spring, 25 times in 80 seconds. The period is the time divided by n. What is the frequency of the spring pendulum? Well, frequency is just inverse period, so that can be n divided by t. What is the spring constant? T is 2 pi L, oh, no, back up. M over K. Solve for K. You got M, that's 0.1. You've got T, the period. And so all you got to do is square both sides, solve for K, and then you got it. So that's just 2 or 3 lines of algebra. Okay, number 7. Number 7 is, on the Earth, the 3 kilogram steel ball on a string oscillates 45 times in 145 seconds. So the period is time divided by n, and period is also 2 pi square root of L over G. So period changes to T over n. That T also equals to 2 pi square root of L over G. Solve for L. G is 10. So it becomes T squared over N squared, 4 pi squared L over G. So this is T squared G over 4 pi squared N squared is equal to L. That's the length of the pendulum. Go to the moon. New period. 2 pi L over G prime. The L is what you get from part 1. G prime is 10 over 6. And then that's it for number 7. Number 8, you were in a wave pool, 30 oscillations in 90 seconds. So the period is T over big N, where little t is 90 and big N is 30. The wavelength is 20 meters, and what we're doing is we're using V equals lambda F. That the velocity of the wave is the wavelength times frequency, and we did an example today in the 1 o'clock. So the period of the wave, you just take little t and divide by big N. The velocity of the wave, you just take lambda, which is 20, and frequency, which is big N over little t, because F is the inverse of period. And then you get that. So that's number 8. Okay. Now I'm going to change things up. I'm going to go backwards. Now I'm on the other side of 9. Number 12. Pendulum on Earth has a 2-second period. What is the pendulum? What is the period of the pendulum if it's moved to the moon? So T is 2 pi L over G. Solve for L. Period squared, 4 pi squared L over G. L is G T squared over 4 pi squared. Take that L, put it in here. G prime is 10 over 6. Number 11. A 0.65 kilogram cord is tied between two trees. Tension is 240 newtons. How long does it take for the wave to travel from one tree to the other? I don't think that question can be done. Because the velocity of a wave in a string is just t over lambda. Oh, I think I may have, ooh, this is a subtle thing. The velocity is t over lambda, where lambda is the mass density, or m divided by big L. So the velocity is the square root of t times L over m. And that's the velocity in the string. Velocity times time is distance. Or in our case, it's going to be v times t is equal to big L. Oh, we will have, do we have to know what? Oh, so we're going to solve for t. Big L over v. That means we have big L over the square root of TL over m. M is 0.65. T is 240. We do need to know what L is. So I'll just say the distance between the two trees is, make it 10 meters. Make the distance 10 meters and then give me a number. So L is 10. Problem 10. Now problem 10, that's more of a motion problem, but we'll do it anyway. Velocity of one type of wave, the P wave, is 8.5 kilometers per second. The velocity of the S wave is 5 kilometers per second. You get hit by the P wave, and then 90 seconds later, you get hit by the S wave. So what we're really doing is we're studying earthquakes, because there are P waves and S waves, and when you do get hit by a really big earthquake, you'll actually feel two, because you get hit by the S wave second, but before that you get hit by the P wave. There's actually a precursor earthquake that you'll feel before the other earthquake hits, and it's because of the rock shifting in different directions, and one type of wave is a transverse and the other one's a longitudinal, and they move at different rates. In either case, the epicenter and U are at the same distance L. Both the P wave and the S wave must start at the epicenter and then they head towards U. So at t equals 0, you get this. At some time t, the p wave is at you, and the s wave is slightly behind. And then at t plus 90, you get hit by the S wave. So S and P start here, and as it gets to you, the S and the P wave separate because the P wave is faster. And then 90 seconds later, the S wave hits. In both cases, they use the same L. So the velocity of the P wave getting to you, since velocity is distance over time, is L divided by TP. The velocity of the S wave is L divided by TS, or you could write it as VS is L over TP plus 90. The time for the S wave to hit you is the time that it takes for the P wave to hit you plus 90 seconds. What we do for both is that VSTS is equal to L and VSTP plus 90 is equal to L2. Oh, and this is not VS, this is VP. So it ends up becoming that VP TP plus 90 is equal to what? What am I doing? Oh, yeah. That noise is annoying me. I'm getting confused. VS is L over TS. So VSTS is equal to L. VP. Oh, this is TS. Or, it's actually T. Now I'm definitely getting annoyed by the fan. I can't think. The fan is just messing me up. I'm psyching myself out. Hold on. I'm gonna start this new. I got time. So VS is L over TS. VP is L over TP. And what we're gonna do is we're gonna change everything so that we're going to eliminate the time S, because we're going to change it to TP plus 90. TS is TP plus 90. That means VS TP plus 90 is equal to L. And then L also equals VP TP. There we go. Because I know the two velocities. TP is the only variable. So VS TP plus VS 90 is equal to VP TP. Move this over here. 90 VS VP TP minus VS TP. or 90 VS is TP VP minus VS. So the time that it takes for the P wave to hit you is this value here. That's what you need to do. And now that you have the time that it takes for the P wave to get there, that distance L is just the velocity times time. And then you're done. Done, done, and done. With a side order of done. And that's it. Okay. Bye-bye.